All right, so we just finished solving using factoring. Does everything factor? No. Some things you can only factor so far, and then you can't do anything with them. So we need other ways to solve other than factoring. Okay? So this chapter that we're in, chapter 4, deals with all quadratics, meaning x squared. So everything that we deal with is x squared. Chapter 5, which we'll get into after next week, so when we come back from President's Day, we'll get into chapter 5. Chapter 5, we deal with like x cubed, x to the 4th, x to the 5th, x to the 6th, and so on. Do you remember what we talked about? Like if it's x squared, how many answers it has? 2. If it's x to the 5th, how many answers would it have? 5. So everything in this chapter deals with x squared. Everything has 2 answers. Okay? Moving into next chapter, you'll have a lot more. But right now, the only way we have to solve is factoring. But everything doesn't factor, so we need other options. This section 4.6 has square root method and completing the square. Normally, I teach both methods. We've missed so much school at this point, something had to go. Okay, so we are taking out completing the square as one of your options for solving. As far as grand scheme of things, in this class, students completed the square in this chapter and then never touched it again. Now, factoring, all semester. Square root method, all semester. Quadratic formula, all semester. So if there was anything we were going to cut, it's the one thing that we really only use in this chapter. Okay? So has anyone ever learned how to do completing the square? Okay. You're not missing much. I'll be honest, even as a math teacher, like it's fun to do that method and it's fine, but it's never my option like I go to, ever. Okay? So just so you know, we are taking that out. Okay? All right, so I gave you a pink paper that has this on it. You can put a big old X through the completing the square because we are not going to be doing that. We'll take that out. So this whole process won't be as bad since I took one of your options away for solving. Okay, so you're going to have 3 options to solve. Factoring we've already done. Square root method we'll do today. Quadratic formula I'm going to teach you tomorrow. Has anybody ever learned quadratic formula? A couple of you? Okay. The negative b plus or minus the square root, all that stuff. Okay. So that'll be tomorrow. But what I want to do is kind of organize for you guys, like step by step, how we do each method. And it's not as bad, again. This one was the most, like, people messed up on the method part. So that one's out of the question. But factoring, what's the first thing you did in factoring? If I gave you a problem, I said solve that by factoring. What's the first thing you do? Before GCF even. What? No, not simplify. Oh my gosh, you guys just took a quiz yesterday and did well on it. Set it equal to 0, thank you. So the first thing you did was you set it equal to 0, meaning you had it as ax squared plus bx plus c equals 0, right? That was the first thing you did. Set it equal to 0. So a lot of times you had to move things, right? What'd you do after you set it equal to 0? Look for your GCF. So you factor the GCF. Then what? What'd you do after you took the GCF out? Okay. Right, I took it out. That's what factor GCF means I'm taking that out. How did your factoring always break down? 2 parentheses. Right? You factored. That's actually the factoring process, right? So you'd factor. And then what? I just find them. They're hidden somewhere. Perfect. I know it's entertaining for me to listen to you guys attempt to. Sometimes people say it like really well. I'm like flat out impressed. And other times I'm like, I know you know what it is, but like I'm just trying to pull those words out of you guys. You will set each factor equal to 0 and solve. All right, so that's the method we just worked on. Just so you have it in your head, like this is the process. Okay? Now the square root method, It's got a different process. We're not going to start by setting it equal to 0. That's not the first thing we do anymore. Okay, so for square root method, the first thing you're going to do is isolate the x squared or parentheses squared. Kind of depends on what your problem looks like. What's isolate mean? Get it by itself. Good. Isolate the x squared or the parentheses squared. It's going to be the first thing you do. Then you're going to take the square root of both sides. This will make more sense in a minute, but don't forget the plus minus. We'll talk about that in just a moment. I would say more people miss points from that step right there because they forget that than anything else. All right, and then solve for x / simplify if necessary. Kind of depends on the problem. Doesn't seem so bad though, right? Get the squared thing by itself, take the square root, simplify, solve for x. Yeah, it's not so bad. I would say as far as methods for solving, that one's probably the easiest because there's not a lot of steps to it. The only bad thing is a lot of problems don't actually fall into this category. Because the big thing, you can go ahead and make a note of this up here, it must be missing the bx term. Right, we have ax squared plus bx plus c. So it does not have that middle bx term. That piece is missing. If it's missing it, then you can use the square root method. All right, we ready to dive in? You're excited now, right? All right, so solving by finding square roots. So back to your note packet. You can only solve a quadratic equation by finding square roots if there is no blank term in the equation. Which term is missing? bx. So for example, which equations are missing the bx term? So there's 4 equations. How about the first one? Is that missing the bx term? Yeah, there's 3 pieces here, but you got like terms, and this is like technically your c value. So that one's missing the bx. What about the second one? No, the bx term is sitting right there. That's not missing it. The next one? No, there it is right there. What about that one? Is it missing it? Yes, it's missing it. I heard a no from somebody. All right, so if it's missing the plane x, those are the ones this method works on. What type of factoring is missing that bx term? There's a type of factoring. It's my favorite.
The one where it's like
The difference of squares. Yep, difference of squares is missing the bx. All right, so to solve by finding square roots, isolate the x squared or parentheses squared. Then take the square root of both sides of the equation. And again, we kind of already just put that on our pink sheet. All right, so here we go. Solve the equation by finding square roots. So based on my steps, it said to isolate the x squared first. So what do I need to move? The 25. So I need to add 25 to the other side. Right, negative on this side flips to positive 25 on the other. What do we do next? What did your steps say to do after you isolate it? Take the square root. Because what's the opposite of squaring something? It's square rooting it. So if I take the square root, I have to do both sides, right? We got to keep it balanced. If I do something for one of my kids, I should do the same for the other, or they all get mad at me. right? We got to keep it balanced, keep it fair. What's the square root of x squared? Is x. All right, what's the square root of 25? 5. Now, didn't we talk about if it's x squared, it has how many answers? Why do I only have 1? I should still have 2. What's 5 squared? What's 5 times 5? 25. Negative 5 times negative 5? Still 25. This is plus minus. So the part of your notes where I said don't forget the plus minus, the rule is anytime you take the square root of something, your answer is plus minus. Every time you take the square root. Okay? Now, if you're given a problem with a radical already in the problem, that's different. If you yourself introduce the square root sign into the problem for the first time, your answer is plus minus. Okay? Yes? Yeah. It's faster. But no, let's go back to that though. So you guys just took a test yesterday, or a quiz yesterday, right? Over factoring. If I had given this to you and I said factor, it's already said equal to 0. 2 terms, minus sign, perfect squares. How does that factor? X plus 5, x minus 5 equals 0. So you would have set each one equal to 0 to solve. So you would tell me x equals negative 5 and x equals positive 5. Positive 5, negative 5. Positive 5, negative 5. I get the same answer. But does everything that's missing the bx term, are they always perfect squares? No, they're not. So they don't always factor like we want them to. Yeah, there's a lot less work there. Yeah, look at the difference in my work. A lot less going on over here. Okay? You know me, I'm a lazy mathematician. If I can do it in less steps, less work, that's what I'm going to do. All right. So what about number 2? X squared minus 12 equals 0. So before today, if I had given that to you, would you have been able to factor it? No. You have 2 terms and a minus sign, and x squared and 12 is not a perfect square. So you'd have been like, I have no idea. Right? That would not have factored. So now, though, we have another method. Right? If there's no bx term, so I can use this method. Let's add the 12 to the other side. Because step 1 is to isolate your squared, the x squared or parentheses. Once it's isolated, you take the square root of both sides. Square root of x squared, it's just x. Is the square root of 12 nice and pretty? No. Do I type it in my calculator and get a decimal? No. No decimals in this classroom. All right, well, we can do a factor tree. So that's going to become 2 radical 3. And what do I need to remember? What's that rule anytime I take the square root? Plus minus. So now I have 2 answers, a positive 2 radical 3 and a negative 2 radical 3. Yeah. Pears come out, leftovers in the fridge. All right, so what about 33? Or 33? 3. There's a 33 next to it. What do I do first on that one? Do we equal these to 0? We get the squared part by itself. So you have some options here, but let's go ahead and subtract the 33. So I have negative x squared equals negative 27. Is my x squared by itself? No. Okay, there's a negative 1 technically sitting here. So we have to divide by the negative 1 to get it by itself. Negative 27 divided by negative 1 is positive 27. Once it's by itself, Take the square root of both sides. All right, 27, pretty and perfect? Nope, so factor tree. So we get a pair of threes, so 3 comes out, and a leftover 3. All right, is my answer good? 3 radical 3. No, what's wrong with it? Yeah, I need the plus minus sign. Anytime you take the square root, it's plus minus. Megan? You're welcome. Ben?
We would have like factored x squared, or like added x squared, and then moved to the other side,
Mm-hmm.
and then subtracted 6 from that side.
Perfect.
Okay.
Yep, you still end up same spot. Doesn't matter. Nope. Okay, number 4. Look at your x squared. There's a 2 over there and there's a 9 over there. Which one do I get rid of first? The 9. Okay, so we're going to subtract the 9. So we have 2x squared equals 4. Do I take the square root right now? I have students every semester I teach this. Think they're like, yeah, I'm good. My x squared's by itself. No, it's not. There's that 2 sitting in front. We got to get rid of that first. Divide by 2. So x squared equals 2. Then what? Take the square root. So x equals, can I simplify square root of 2? No. So that's just plus or minus radical 2. And there's my 2 answers. Damien? Sure? You okay? All right, number 5. What do you do with that one? Nope. Try again. Look at your paper. What's it say your first step is? Does it say set it equal to 0? No, factoring is equal to 0. This one is isolate your x squared. So I'm going to subtract 3. So negative 5x squared equals negative 12. Thank you. Divide by negative 5. So x squared equals, what's negative 12 over negative 5? $12 over 5, thank you. 2 negatives make a positive, so that part simplifies. Do not, I repeat, do not turn that into a mixed number. Okay, when we do square roots, we like to do top of fraction, bottom of fraction. We don't do mixed numbers. All right, so now when I take the square root on both sides, do not, this is what I get all the time, I get this. What do you think is going to happen? They're going to forget the very first rule that says to split your radical. And then people leave a radical on the bottom and it's not simplified. Okay? Don't do this. If I'm taking the square root of a fraction, I'm doing top and bottom. I'm going to make my life easy. I'm going to split it as soon as I go to do it. All right, so square root of 12. It's not pretty, but we can do a factor tree on that again. Good. If you remember from before, it is 2 radical 3. Radical 5? That's just going to say radical 5. Is that a good answer? Yes. Multiply top and bottom by radical 5, because we can't leave that darn radical on the bottom. So we get x equals 2 radical 15 over 5. Good? Beautiful? Done? Plus and minus. Do you see how easy it's going to be, though, to forget that plus minus? Yeah. If nothing else, get it stuck in your head. It's x squared. I have 2 answers. I need 2 answers. One's positive, one's negative. That's your plus minus. Sure. How are we doing so far? Okay? Wow. That was deep. Why don't you guys try number 6 on your own? All right, guys. Number 6. First thing is subtract your 7 to both sides. So 3x squared equals 16. A couple of you attempted to take the square root of both sides right there. Okay, that is not by itself. We have to divide by the 3. X squared equals 16 over 3. That does not divide or simplify. Then you can take the square root. A couple of you wrote a giant radical over your whole fraction and messed yourself up. Fractions, we take top and bottom separate. So x, oops, not squared, x equals square root of 16 is just 4. The radical 3 I can't do anything with, but we can't leave a radical on the bottom, so multiply top and bottom. So we get 4 radical 3 over 3, and don't forget your plus minus. So plus or minus 4 radical 3 over 3. Every time you forget the plus minus sign, it's minus 1, because you've lost an entire answer. You lost the whole negative 1 if you don't put that down. All right, number 7. What do you do first on 7? Looks very similar to this same setup, right? Why would I put this problem on here? Yep. When you subtract the 19, you get 3x squared equals negative 16. Divide by 3. Negative 16 over 3. Is this different? What's different? There's a negative. How's that going to change my answer? It's going to have an I in it. Yep, so when you take the square root, top, bottom, the I is going to come out. So you're going to get 4i over radical 3, and then multiply top and bottom. So plus or minus 4i radical 3 over 3. I know I went fast, but it is in essence the same as this problem. The only difference is when you have a negative, it's going to make an I in your answer. It's imaginary. Next chapter, when we get into this, that means that answer would not show up on a graph. If you'd graph that equation, it would not cross the x-axis. This one would. Okay. All right. A couple more of this type, and then we're going to switch gears a little bit. So number 8, what do you do first? Add the 2. So 4x squared equals negative 15. Divide by 4. So x squared equals negative 15 fourths. Then what? Square root, thank you. I have like 2 people who will speak to me. Did I do something, you guys, make you not want to talk to me? Did I scare you or something? All right, when you take the square root of a fraction, what do? Make a big giant one? No. Top and bottom separately, please. So x equals plus or minus. What happens on the top? It gets an I, but then the radical 15, if I do a factor tree there, you get 3 and 5, so it stays there. Square root of 4? Ooh, 2. Do I have to rationalize anything? No, I'm done there. Some of you have a tendency to try to rationalize right from the start, and you make things so hard on yourself. Again, simplify everything first. Last thing you want to try is to rationalize. Okay? All right, are we feeling okay? Can I skip 9? We okay? I'll do it if anybody needs me to. We okay? Anybody? Uh-oh. All right, he said he tried to do it and didn't know how, so we'll do number 9. What's the first thing to do? Yeah, minus 27. The first step is always to isolate that squared. So x squared equals negative 24. Okay, so my square term's by itself. Then what? Yeah, radical. Take square root of both sides. So x equals plus or minus, I know my answer is going to have what? An I. And if it's not perfect, we factor tree. That is correct. All right, pair of 2's, Don't lose your eye. Left over 6, and that's it. There's no fraction to be had on that one. All right. Do we need a break? Need a breather? Yeah. All right, we're going to switch gears just a little bit. We are still solving using the square root method. Sean, can you sit on your butt, please? So still using the square root method, right? Because in your step-by-steps, I said to isolate the x squared or the parentheses squared. This is that type, okay? So number 10 has x minus 3 in parentheses squared equals 49. This is still a quantity squared. We can still use this method. Okay, so if we take the square root of both sides, because it's by itself, what's a square root of x minus 3 squared? It's x minus 3. Right? The radical and the square, they kind of cancel each other out. Square root of 49? Just 7?
7. The square root of 49 is 7.
Plus or minus 7, right? We wrote that radical over that, so that answer is plus minus. Now, normally we were done, right? Took square root, there we go, plus minus, I'm finished. But then I also put the step on there to solve for x or simplify as needed. X is not by itself. We need to add this on this side. Now, I'm writing it this way for a very important reason. That negative 3, when it moves to the other side, becomes a positive 3. But then I have 3 plus or minus 7. That is not plus or minus 10. That's why I wrote it that way as opposed to underneath it. What's 3 plus 7? 10. And what's 3 minus 7? Negative 4. Those are your two answers. Plus or minus implies that it's a positive 7 and a negative 7. Okay, it's two different answers. Every year I have students write plus 3 underneath here, and then they're like, oh, that's plus or minus 10. No, negative 10 doesn't work. Negative 10 minus 3 is negative 13. Negative 13 squared is not 49. Okay, it doesn't work. Okay, so when you have a plus or minus just a regular old number, that's why I just kind of move that on over there, and then I can see it side by side. You have a better chance of not messing up when you do it that way. All right, number 11. Is the parentheses squared by itself? Yes or no? Is the parentheses part by itself? There's a 2. Am I allowed to take this 2 and distribute into here? Yes or no? I'm not. Since it has that little squared on there, it's kind of like holding all that prisoner. It's not letting anybody else in. I cannot do that. But that's being multiplied, so I can divide it to undo that. I'm trying to get the squared part by itself. And now I have y minus 1 squared equals 25. Now my parentheses squared is by itself. So I can take the square root of both sides. What's the square root of y minus 1 squared? Y minus 1. Square root of 25? Thank you. Plus or minus 5. Some of you are getting the hint when I pause and don't write something down. And then to get y by itself, plus or minus 5. Oh. Do I stop there or do I keep going with that? Keep going, because what's 1 plus 5? Is 6, and 1 minus 5 is negative 4. So I can actually write the two answers, okay? Now, the question is, will that number I take the square root of always be nice and perfect like that? No, it will not. Ta-da, that's the next part. All right, so number 12, what do I have to move first? That's 3, right? I can't distribute in because that squared's there. But we can divide both sides by 3 to get rid of that. So x plus 2 squared, 30 divided by 3 is 10. Now am I ready to take the square root? Yep, my squared part's by itself. So square root of both sides. So x plus 2 equals, good, plus or minus square root of 10. I can't simplify that, right? There's nothing I can do with a 10. Okay, and I have to get x by itself. So again, I'm just going to move that on over. What happens to the 2 when I move it? Negative 2 plus or minus radical 10. Are those like terms? Like on this problem, these, I had it to this point, and then I went ahead and told you the 2 answers. Can I do that with this problem? No, they're not like terms. It's got a radical on it. I doesn't go with anything else. So then I'm just done there, which is even easier, right? I don't even have to go an extra step. Question, Ben, are you okay?
So, I was thinking, if it possibly negative, that would make it so the answer would possibly be I. No.
The I would come from if the number I took the square root of was negative. That's where the I would come from. The fact that there's a negative out here doesn't matter. Good question, though. All right, what about 13? People panic when they see a fraction. How do I get rid of the 1/3? I can multiply by 3, or those of you who really hate fractions, is that not just 1/3 times x plus 5 squared? So what's the opposite of multiplying by 1/3? Dividing by 1/3. I agree. In my brain, I see that as I just multiply both sides by 3 to get rid of it. But not a lot of people always see it that way. I can still attack it the same way I attacked this one. It's no different. 1/3 is just a number. Okay? So same idea. So it's still x plus 5 squared equals 7 divided by 1/3 is the same as 7 times 3, which is 21. But again, if you're uncomfortable with the math of the fractions, just use your calculator. I can still attack it the same way. Okay? All right? Then what? Square root. So I get just x plus 5 equals, good. Factor tree there, it's just 3 and 7, so no pairs. And then I have to get x by itself. Perfect. And I don't go any steps further because those are not like terms. What are we thinking of the square root method so far? Pretty good? I actually do not give you an IXL assignment over this. IXL gives all of the answers in decimal form. What do we know about decimals? That's right. Good answers. Good answers. Are decimals exact? No, they're not. Every decimal answer, it'd be rounded off. So that's why we leave them here. IXL, that's terrible. All right, is this the last one I have on there for you guys? All right. So this problem, what do you do first? Oh, I just subtract, that's it? Yeah, okay, good. I subtract 13. So x minus 3 squared, 4 minus 13? Okay. Then what? Square root. What's the square root of negative 9? I.
Oh.
Negative underneath there. But you remember the plus minus, that was good. 3i. Am I done? No? I got x by itself, right? I'm solving for x. So I move that over. So x equals, that becomes positive 3 plus or minus 3i. Am I done now, or can I go the extra step like I did on the first two of these types? Like terms or not? They are not. So I am done. The only time it's like terms is if there's no radical and no I and they're just numbers, then yes, you can put them together. If it has an I or a radical, it's not like terms. Okay? Yay, we doing all right? Square root method? Now, I had printed all of these notes back before we had a million snow days and all that other fun stuff. So you have completing the square notes in there. We are not going to do that section. Okay? If you were like, I wonder what completing the square is, and you want to look at it, by all means, it is broken down step by step in there for you, but I am not going to actually teach that to you.